Hi friends, in this video we are going to learn about motion. Let's read this chapter quickly and we'll solve the question based on it. Let's start. Scalar quantities. Physical quantities which have magnitude only and no direction are called scalar quantities. Example, mass, speed, volume, work, time, power, energy, etc. Vector quantities. Physical quantities which have magnitude and direction both and which obey triangle law are called vector quantities. Example, displacement, velocity, acceleration, force, momentum, torque, etc. Electric current, though has a direction, is a scalar quantity because it does not obey triangle law. Moment of inertia, pressure, refractive index, stress are tensor quantities. Distance. Distance is the length of actual path covered by a moving object in a given time interval. Displacement. Shortest distance covered by a body in a definite direction is called displacement. Distance is a scalar quantity, whereas displacement is a vector quantity, both having the same unit, that is meter. Displacement may be positive, negative, or zero, whereas distance is always positive. In general, magnitude of displacement is less than or equal to distance. Speed. Distance traveled by the moving object in unit time interval is called speed, and the formula of speed is distance by time. Speed is a scalar quantity and its SI unit is meter per second. Velocity. Velocity of a moving object is defined as the displacement of the object in unit time interval. That is, velocity is equal to displacement by time. It is a vector quantity and its SI unit is meter per second. Acceleration. Acceleration of an object is defined as the rate of change of velocity of the object. That is, acceleration is equal to change in velocity upon time. It is a vector quantity and its SI unit is meter per second square. If velocity decreases with time, then acceleration is negative and is called retardation. Circular motion. It should be if an object describes a circular path, its motion is called circular motion. If the object moves with uniform speed, its motion is uniform circular motion. Uniform circular motion is an accelerated motion because the direction of velocity changes continuously. Angular velocity. The angle subtended by the line joining the object from the origin of circle in unit time interval is called angular velocity. You can see the diagram of angular velocity here. Diagram showing angular velocity. It is generally denoted by omega, and omega is equal to theta by time. If t is equal to time period is equal to time taken by the object to complete one revolution, n is equal to frequency, that is number of revolution in 1 second, then nt is equal to 1 and omega is equal to 2 by t, which equals to 2 pi n. In one revolution, the object travels 2 pi r distance. Linear speed is equal to omega into radius. Omega is angular speed into radius. Newton's law of motion. Newton, the father of physics, established the laws of motion in his book Principia in 1687. Newton's first law of motion. Everybody maintains its initial state of rest or motion with uniform speed on a straight line unless an external force acts on it. First law is also called law of Galileo or law of inertia. Inertia means the property of a body by virtue of which the body opposes changes in its initial state of rest or motion with uniform speed on a straight line. Inertia is of two types, inertia of rest and inertia of motion. Some examples of inertia. When a car or train starts suddenly, the passengers bend backward. This trend is called inertia of rest. Next, when a running horse stops suddenly, the rider bends forward. This is an example of inertia of motion. When a coat blanket is beaten by a stick, the dust particles are removed. Shows inertia of motion. First law gives the definition of force. Force is that external cause which, when acts on a body, changes or tries to change the initial state of the body. Momentum is the property of a moving body and is defined as the product of mass and velocity of the body. That is, momentum is equal to mass into velocity. It is a vector quantity. Momentum is a vector quantity and its SI unit is kilogram meter per second. Newton's second law of motion. The rate of change in momentum of a body is directly proportional to the applied force on the body and takes place in the direction of force. If F is equal to force applied, A is equal to acceleration produced, and M is equal to mass of body, then NF is equal to MA. Newton's second law gives the magnitude of force. Newton's first law is contained in the second law. Newton's third law of motion. To every action, there is an equal and opposite direction. Examples of third law: recoil of a gun, motion of a rocket, swimming while drawing water from the well. If the string breaks up, the man drawing water falls back. Next, principle of conservation of linear momentum. If no external force acts on a system of bodies, the total linear momentum of the system of bodies remains constant. As a consequence, the total momentum of bodies before and after the collision remains the same. Impulse. When a large force acts on a body for very small time, then force is called impulsive force. Impulse is defined as the product of force into time. Impulse is equal to change in momentum. It is a vector quantity, that is, impulse is a vector quantity and its direction is the direction of force. Its SI unit is Newton second. Next, centripetal force. When a body travels along a circular path, its velocity changes continuously. Naturally, an external force always acts on the body towards the center of the path. The external force required to maintain the circular motion of the body is called the centripetal force. If a body of mass m is moving on a circular path of radius r with uniform speed v, then the required centripetal force F is equal to mv square by capital R. Centrifugal force. In applying the Newton's law of motion, we have to consider some forces which cannot be assigned to any object in the surrounding. These forces are called pseudo-force or inertia force. Centrifugal force is such a pseudo-force. It is equal and opposite to centripetal force. Cream separator, centrifugal dryer work on the principle of centrifugal force. Centrifugal force should not be confused as the reaction to centripetal force because forces of action and reaction act on different bodies. Moment of force. The rotational effect of a force on a body about an axis of rotation is described in terms of moment of force. Moment of force about an axis of rotation is measured as the product of magnitude of force and the perpendicular distance of direction of force from the axis of rotation. That is, moment of force is equal to force into moment r. Moment of force is a vector quantity. Its SI unit is Newton meter. Center of gravity. Center of gravity of a body is that point through which the entire weight of body acts. The center of gravity of a body does not change with change in orientation of body in space. The weight of a body acts through center of gravity in the downward direction. Hence, a body can be brought to equilibrium by applying a force equal to its weight in the vertically upward direction through center of gravity. Equilibrium. If the resultant of all the forces acting on a body is zero, then the body is said to be in equilibrium. If a body is in equilibrium, it will be either at rest or in uniform motion. If it is at rest, the equilibrium is called static, otherwise dynamic. Static equilibrium is of following three types. Stable equilibrium. If on slight displacement from equilibrium position, a body has tendency to regain its original position, it is said to be in stable equilibrium. Unstable equilibrium. If on slight displacement from equilibrium position, a body moves in the direction of displacement and does not regain its original position, the equilibrium is said to be unstable equilibrium. In this equilibrium, the center of gravity of the body is at the highest position. Neutral equilibrium. If on slight displacement neutral equilibrium, if on slight displacement from equilibrium position, a body has no tendency to come back to its original position or to move in the direction of displacement, it is said to be in neutral equilibrium. In neutral equilibrium, the center of gravity always remains at the same height. Conditions for the stable equilibrium. For stable equilibrium of a body, the following two conditions should be fulfilled. First, the center of gravity of the body should be at the minimum height. Next, this vertical line passing through the center of gravity of the body should pass through the base of the body. These two were two conditions for stable equilibrium. Now we will solve the questions based on what we read. First question is, what are the examples of scalar quantities? Answer: mass, speed, volume, work, time, power, energy, etc. are the examples of scalar quantities. Next, what are the examples of vector quantities? Answer: displacement, velocity, acceleration, force, momentum, torque, etc. Next, what kind of quantity is electric quantity? Electric current. So electric current is a scalar quantity. Next, what is a tensor quantity? A tensor quantity is a physical quantity that is neither vector nor scalar. Next, what are the examples of tensor quality? Answer: moment of inertia, pressure, refractive index, stress are tensor quantities. What is the SI unit of speed? Answer: meter per second. What is the formula of velocity? Answer: displacement by time. What is the SI unit of velocity? Answer: meter per second. What is the formula of acceleration? So its formula, acceleration is equal to change of velocity by time. What is its SI unit? What is the SI unit of acceleration? Answer: meter per second square. Next, first law of motion is also known as law of Galileo or law of inertia. Next, which law gives the definition of force? Answer: first law gives the definition of force. What is the formula of momentum? Answer: momentum is equal to mass into velocity. Next, what is the SI unit of momentum? Answer: kg meter per second is the SI unit of momentum. Next, which law gives the magnitude of force? Answer: Newton's second law gives the magnitude of force. Next, what are the examples of Newton's third law? Examples of third law are recoil of a gun, motion of rocket, swimming, while drawing water from the well. If the string breaks up, the man drawing water falls back. Next question, what is the formula of impulse? Its formula is force into time, which is also called change in momentum. Next, what is the SI unit of impulse? So, SI unit of impulse is Newton per second. As force SI unit is Newton and time second. So, impulse SI unit is Newton second. What kind of quantity is impulse? Impulse is a vector quantity. Next question. Which force helps in cream separation from milk? Answer, centrifugal force. That's all for today. Thanks for watching. If you like the video, please subscribe this channel